Hi guys, okay, and welcome to another video. Today, we will talk about once again about React, and specifically about three things, or three hooks in React, which are useState, how you can use it properly. Well, let's say that is, in my personal opinion, the most recommended way to use it, and useEffect and useRef. Now let's talk about useState first. Now, what is useState? Well, useState is a way to actually declare, well, a state in React. Now, state is pretty much, let's say, a variable, but in this case, this variable can be manipulated with a second function, which is what we call a state setter. Now, fret not, useState is pretty much just a function built in React to help us manage our variables, or we can call it states, in our application. Because if you rather because since React actually creates an imaginary DOM or a virtual DOM as they call it, we need a way to actually, let's say, store our values or state alongside that virtual DOM. And since the way that React re-renders or rebuilds its virtual DOM is by checking if a state has changed or if one of its variables, which is declared in useState, has changed. Now, what is the virtual DOM? Well, virtual DOM is pretty much just a copy of the real DOM, and the real DOM is pretty much what you see in the browser, or in a deeper level, they are the properties that we see in each element. Now, the important keyword here is a copy. So now, the virtual DOM copies the contents of the real DOM, and then it will listen for state changes, and those are declared with useState. Now, if the value, for example, 0 changes to 1, then React will re-render and it will look for the things that changed. And in this case, the count has changed from 0 to 1. Now, React will look for the nodes, or let's say parts of the DOM. Now, what I mean is that the elements, for example, we have this right here, which is displaying the count. Now, React will look for each of this logo, this text, this button, and so on and so forth. And when it lands on this button, or rather this right here, which is displaying the count value, it will know that it actually changed. It will compare it to the previous value, which was 0, and now it is 1. So now that it changed, it will update the real DOM to display the new count. So if I click this, there we go. Now this is important to know when you are developing or starting out in React, because this is the most optimal way that you can actually have variables or store values in React. Because React is mainly about re-rendering, like rebuild the overall component. That's why it's very interactive. And now this is what we call a component right here. Pretty much still just a function that returns a JSX. And JSX is pretty much, let's say, a superset of HTML, like a superpower, let's say. HTML on steroids, I don't know. But the difference with JSX and HTML is that JSX has a casing of, is it Camel or Pascal? I think it's Camel. Yeah, anyway, Camel I think is like the first letter or first word will have its first letter start with a small lowercase, while the following words will have its first letter in uppercase. But of course, area labels are an exception for this. If you check area label, there we go. Okay, anyway, let's talk about how we can update a state. Now, if you check down here, we have the button that listens for when a user clicks on it. And when a user clicks on it, this will run a callback function, which is what we see here. This is a callback function, which will then trigger this set count right here, or invoke this set count. And now this set count is what we call the state setter. And what this pretty much means is that we want to set the count to whatever value is passed on inside of this function. How do we get the set count function? Well, it's pretty much what is given by the useState hook. Okay, let me walk you through this right here. Now, this useState is a function, so we need to invoke it right here. And we can pass it any value that we want our state to have. Now, we can actually have this at first as undefined, but of course, since we are dealing with counts, well, we would like as much as possible to have our default value as 0. Now you can have any kind of value here as the default value of your state. And now what this gives us back is an array of two things. The first item would be the state itself or the variable, which contains the value that we provided inside of this function. So, and the second one is the state setter, which is a function that allows us to change the value of this state or variable over here. Now, if we provide no value here, then the value of the state or variable would be undefined at first because, well, we provided no value. It is undefined. So take note that when you provide this no value at all, it will be undefined by default until you change the state's value. That's why as much as possible, you can provide it a default value. Well, let's move on to how we can update it. Now, if you've seen some people, let's say, update a state with a state setter, most of the time, and I did as well, they do something like set count plus 1. Now, what this means is that they are using this variable, which is holding the value of the state, which is named count in this case. They are using this right here and then adding it, and then that will be the new value of the state. Now, there's generally nothing wrong with this. However, with this method, this implies that we actually depend on the value of this variable here, or of this state, which is count. And now this holds the value of the state. Now, where or when will this become a problem? Well, let's just say that first, let's make a function called increment, I guess we can call it. And on top, we can make a function called increment. Same time, we have function increment. There we go. And this increment will pretty much just update the state. Now let's try this out. Generally, there's nothing wrong with this at first glance. So let's try. Let's count. There we go. As you can see, we are changing the state just fine, or well, incrementing the value of the number or state count just fine. Now let's try to actually add another one. Let's see what happens. So what this means is that we actually want to increment this by 2, right? We want to double the amount of the value. Oh, not really double. Only just increment it twice, yeah. We want to increment this twice. So let's see if that will work. One, two. Okay, it does not work. Why is that? Well, that's because this state setter value, which is count plus 1, is depending of the value of the state up here. And when a, let's say, state changes, or let's say, let me say it in a different way, this state right here will remain the same until the next re-render of this overall component. Now, what does that mean? Well, let's just say that even if we change the value of the count over here, the value of this variable called count, or the value that this is holding, will still be the same because the component still has not finished re-rendering, or it is what they call life cycle. Now, this is what is available outside, or what is returned by the useState. But then, how can we access the new value? Or like, when we change this, we actually want to get the updated value even if the component has not re-rendered yet. Well, we can do with what we call as a closure, or pretty much just a callback function, which returns the new value. So we can do something like this, an arrow function. And this arrow function actually has access to the value of the current count. Or we can call this a previous count because we will change it, you know. But anyway, this has access to the value, which is the current count. And now we can just say current count plus 1. Now, of course, you can name this anything you want, but there we go. If you check, it has the value of the number. So now, how is this possible? Well, it is possible because this function, setCount, actually gives us now this is somewhat the same. So this what is happening here is somewhat the same as what is happening up here. So this setCount value up here can also take a callback function, which is what we have as a parameter on the counter function above. And then we will have a, let's say, we can consider this as the internal state of the virtual DOM, which is up here, which will then be available in this callback because and it is what we are going to return down here. And we will just pass it a parameter of the count value, which is, for example, let's just say the value of the state. And now when we call that counter, we will pass it a callback function, which is can be an arrow function. And now this callback function will have the count available to it. Now, I believe, if I'm not mistaken, this is called currying. But we will pretty much just curry the variable over to another function down here. Now, how is this available? Well, that's because when you call a function, it can accept parameters, right? Well, in this counter above function, we are calling it, and this counter is actually returning the callback, which is what we passed down here. And down here, inside the counter function, its parameter, we passed on a parameter of a callback function, or just pretty much a function overall. And this function um, has access to the count because we added the parameter of count inside of this when we called it down here. That is why if you check the console, it's having 1 from 0 to 1. So now if I did it down here again, it will become 2 or not. It will not become 2 because it does not have access to the updated value. Oh, that's my bad. Okay. Now, why is this not incrementing? Well, that's because whenever we call the counter here, we're actually invoking a new value, which is 0. Let count equals 0, it will be a new value. So it will still be at 1. Now, anyway, that is a rough explanation of what is happening down here. And this is very simple because as you can see, every time we call this function, we will actually declare a new value for the count. That's why it will remain the same way. We don't have access to the changed value. Well, to have access to the changed value, we can just make it available outside, like that. And then if I save this, refresh, oh, it's still the same. Oh, right. Oh, I forgot. Oh, goodness me. Oh, mamma mia. Oh, yeah, yeah, yeah. It's because we're pretty much console logging what is returned by this callback, which is count, takes in the parameter of count and then increments that by 1. So now it will return, well, 0 plus 1 count. Whew, I keep forgetting about block scoped and the ideal, like the main behavior of closures. Goodness. Okay. So now if you noticed, we are actually incrementing it now. Goodness me. This is very, very intriguing. Okay, anyway, we were able to increment this now. Why is that? Because we're actually changing the value of the count up here and we are returning it down here. So we declare the value of the count above. So this remains 0. And even if we call this function again, this will still have the same value unless of course we change it inside the function. And it will not preset because if we put it inside of the function, excuse me, like that, then that means this count will go back to 0 each time we call this function counter. So let's try this out. I hope I'm not mistaken again. There we go. It remains at 1. But if we call it outside, then it will not reset back to 0 whenever we call this function named counter. And now this is finally incrementing because we're actually changing the value of the count or mutating its value from 0 to whatever value is returned by the callback that is passed on as the parameter up here. And now this parameter, count, inside of the callback, actually takes in this value above. That's why we are actually changing it or incrementing it as intended. That now earlier we were not incrementing it. Well, that is because we are actually just returning the value of what is returned by this callback down here. Now, what's the difference? Well, up here, we are actually changing the value of the count, which is from 0. We want the count to be equal to the value of what is, or we want the count to be equal, up down here, to whatever value is returned by this callback that we just called. And this callback will take in the parameter of whatever value the count is currently at. So let's say from 0, this callback will take in the value of 0 from here. So this count on the first invoke, on the first call of the counter function, and we will have the callback. This will have the value of 0, and now it will return to us 0 plus 1, which is 1. So now the count up here will now be 1. And we will just return that count like that, which will be 1. Then the next iteration or next call, it will be 2. But if we did it like this, That means we are not changing the value of the count at all. Oh la la. I refresh. There we go. We get to 3. Why is that? Again, because we are saying that when we call this, we want the count to be equal to 0 plus 1. And then over here, we're returning the value of, since count has now become 1 above here. So up here, count equals 0 plus 1 on the first call. Then down here, that means we're saying that this count is now equal to 1. So let's just say 1 plus 1. Return that value. And now what is returned by this overall function is console logged, which is 2. And then the next iteration, it will be the same. 1 plus 1. Now count will be equals to 2. And 2 plus 1, 3. So what is this return doing here? Well, it's pretty much this function is saying that we want to, or rather, we want this function to stop running. So anything below this return is not going to run. We want this function to stop running and return whatever is, well, next to the return keyword. We want this to return the value of, again, whatever is returned by the callback function. And we are returning this function, or we are returning this value, so that means this value is going to be console logged inside the console log function. Oh, I got sidetracked there, but I hope you understood something, I guess. So this is just a rough estimation of how state is handled by React. They give you a callback function, which you will have then access to the internal state that we declared, for example, in this case, count. And of course, this should be returning the count of the callback. So we will have something like this. 1, 2. Okay, I got sidetracked there for a second. Let's move on. Oh, I took a learning lesson as well. Well, I totally forgot about changing the value of the count first. But anyway, now actually, why don't we try, instead of using the callback function, which is what is provided to us inside, or like we have this right here, callback. Instead, let's say we want to increment the count like this, count plus 1. I'm I'm actually curious, will this work? Because we're actually calling this. I think it will not work. Oh, did it work? Oh yeah, I think I did it. Oops. Oh. Excuse me for that. Goodness, this is very interesting. Well, this is because again, we are changing the count and we have access to it. So 0 plus 1, 1. So over here, 1 plus 1 is 2. Again, goodness me. Anyway, if you're curious about what I did there, I pretty much checked if the type of the callback parameter we passed on, or that was passed on this function named counter, is equal to number, then we just did it like this, since 0 plus 1 or count plus 1 is a type of number. And then there, if it's a type of a function, then we just call that function. But anyway, I keep missing the fact that I'm actually changing this. Like down here, we're changing it, and this will still do it like this every call. Well, the one difference from this to this down here is that in React, this will still have the same value. The count will still have the same value, because in React, it actually, let's say, only changes its value every re-render. But if we pass it a callback function, we will have, let's say, we will have access to the internal state even before the function re-renders. And now that is what I'm understanding here. So like it's will like something like a stored value in the virtual DOM. Now, in this case, I'm not sure how it's done explicitly, but yeah, I really got sidetracked. But this is very fun, actually. I hope you understood something. I just went on there and tried to. Oh, that moved my head. Goodness. Let's move on. So in this case, since React will have the same value of the state before it re-renders, then we can just access its internal state by using the callback function, which is current count. And then say we want to increment the current count by 1. Okay, so now let's try this out. This should increment our count by twice. Yeah, by twice. There we go, 2, 4, 6. No, I got sidetracked. But this is important because let's just say that after incrementing, let's say that there will be a condition or something that when it occurs, we want to decrement, you know. Oh, not that. Let's just say that every time we increment, we want to decrement the, oh, goodness. Sometimes I hate autocomplete, but anyway. Then we have the function decrement, and we just want to subtract it by 1. So now, with this method, oh, no, not like that. There we go. Let's see if this will actually stay at 0. Hey, what do you know? It stays at 0. Well, that's because, again, we have access to this, to the new value of the current count, even before the state or the component re-renders. Let's actually try like doing it like this. Count minus 1. I think this will just increment or rather decrement. Let's try. Or will this stay at 0? Yeah, there we go. Now, again, this is happening because even if we're changing it the right way down here, we are still using the value of the count up here, which only changes before the component re-render. So that means even if we change this to 1, so 1 minus 1 is 0, remains 0, this will neglect the fact that the new state before the component renders has actually become 1 now. But in this case, it is saying that, oh, we want to take the value of the count. Well, the value of the count is still 0. So we just say 0 minus 1 and set that to the value of the state. Then we'll make that the new value of the state count. So 0 minus 1 is negative 1, and so on and so forth. Okay, I think that state covered. Oh, actually, one more thing is because I was actually confused at this by first, but why is it that when we do this, it will not actually increment the state? Let's try it out. This will remain at 0. There we go. Well, that's because you need to know about, and I didn't, okay? So I'm just sharing this with you. Anyway, you need to know about post-increment and pre-increment. Now, post-increment, so this overall thing right there in JavaScript can be considered as a function. And this function, which is current count plus plus, returns the old value before it actually increments the variable. And since this callback function is basing off of the fact of whatever is returned, then it will still remain a 0 because this operation returns the old value. It does not care if the value gets incremented or not. It only cares about what is returned. So to do what you want, we can just say prefix or pre-increment because pre-increment returns the new value right off the bat. So if I save this and refresh, there we go. Okay. Oof, that took 30 minutes to talk about useState. Well, mostly about the currying and such, but anyway. Now let's move on to useEffect. Okay, let's see here. UseEffect, and we actually want there we go. Now, useEffect runs as a it's self-explanatory side effect. We want to use a side effect whenever a component re-renders. So now what kind of side effect do we want this component to have every time it re-renders, let's say? Now, take note, excuse me, take note that we can have conditions for use effect whenever we want it to run. So in this simple call right here, based on what I'm highlighting, this is going to run every time the component re-renders. So we want this component to have a side effect of, let's say, console logging the count, console.log out every time it re-renders. Okay, so now let's try to refresh this and see if it works or not. Yeah, 0, 0, 1, 2, there we go. So now if you noticed, it actually console logged it twice. Well, that is because of the React strict mode that is given to us when we instantiate a React app, or when it is bootstrapped by create React app and Vite. I'm not sure about Next.js, but in this case, it en- um, encloses our app component inside a React that strict mode component. Now, I'm not sure like the main functionality of this strict mode, but I think what this does is that it will rerun the state change, I think. But over here it's actually not rerunning it, so I'm not sure about React strict mode yet, but just take note that you notice this double right here. It's because of strict mode most of the time. Okay, so now this works, but there's a slight problem to this, and that is, let's say we want to have another state, let's say const text set text, also use state, and we will just have an input that will change this value. So let's say down here we have an input, we'll have the value of the text, and on change we want to get its or the event, and we want to set the text to the value of the event's target, which is the input. Okay, so now let's try this out and see that even though we are not changing the count, this will still re-render. There we go. So now why is this a problem? Well, that's because as much as possible in React, we want this to actually remain, or like we want this to not re-render, because this actually uses part of the memory of a user's device. Now, if you're not that familiar as I was as well, memory is pretty much the RAM, and when it's occupied too much, then there will be no more space for other temporary stuff, which will make the user's device lag, or in this case, the browser lag, and it will not be a good user experience. So now how can we avoid this right here? For this use effect to only run when the count changes, because we only care about this use effect or side effect to run whenever the count changes, because we are only console logging the count anyway. Well, there's what we call a dependency array, and that comes after the callback function of the use effect. So again, use effect is pretty much just like useState, which is that it is a function that is available in React to make our lives easier when developing in React. It takes two parameters, the callback function and the dependency array. So it comes like a comma and then an array, and we will pass this any state that we want to keep track of, like count. So what this means is that this will only run if the value of the count, or if the value of the state named count changes. So now if I save this and refresh, let's see if it runs. There we go. Even though we are re-rendering the component whenever we are typing something in the input field, it will not run the side effect, which is to console log the value of the count. Now, this is very important to know about dependency arrays because, like it or not, I've also made mistakes about using useEffect, which is that I changed the state like this before, so count plus 1. Now, since the rule of React is that whatever state or value or variable we use inside of the callback function inside of the useEffect, we need to put it inside of the dependency array. That is because we actually want to access the latest value available inside the overall component whenever the useEffect runs. And when we do it like this, well, we will cause an infinite loop. That's because we are actually accessing the value of the count above here, the state. And so we will pass it down here so that we can have access to the latest value. And now since we're going to change the value of the state, again, this will rerun since it changes. And again and again and again until it, boom, crashes your app. Okay? That's why it's very useful to know about that the state setter accepts a callback function and we will have access to the internal state. So in this case, we have current count, current count plus 1. So now we can actually remove this like so. So let's just say we want to increase the count every time the text changes. Let's say, okay. So let's try to console log the count, console.log count. Let's refresh. There we go. 002. Like so. Okay, I just removed the set count because I remembered that we actually have this as the basis. So now on the first page load, why is this happening? Well, as I've said before, when useEffect is so like useEffect runs once every time the page loads. So like since this component will render on page load to actually show its contents, so that means this inside will run. And since we are using the React.strict mode, this will run twice on first page load. Okay? So now if I try to change, it's working just fine, incrementing the value by 1 every time the value of the text changes. Okay, so I keep saying that this runs twice because of strict mode because I don't want you guys to experience the same stress as I've had before. Still, it's very very fun to tinker around with. That's why I'm actually into this stuff. But anyway, now if you're curious, what if we remove or like what if we have an empty array? Well, since useEffect runs every time the component renders, even once, so like on first page load, to show its content, the component will render. And since the component will render, a side effect will run in here. And now, since we have an empty array or dependency array, which is a condition to say to React that we want to run the side effect whenever the values inside the dependency array changes. Now, since this is empty, then this will not run again anytime the component re-renders. So now if I save and refresh, as you can see, count is 2, and if I did this, nothing will happen. Okay, Very nice. What else can I talk about useEffect? Cleanup functions. Now, what are cleanup functions? Well, cleanup functions are a way to, well, clean up. Now, to explain it much clearer, let's have a timeout. Say we have a timeout here, equals timeout equals to set timeout, and timeout, just like any timeout, let's just say that every second or every 2 seconds, we want to increment. Okay? Now, what will happen here? And of course, since we're using increment, we can say that every time increment changes, or is this correct? Every time increment changes. Yeah, let's fix that. Is it increment or should it be count? Well, let's say we want to run this every time the count changes. Okay, since we're incrementing and count will change, we want the count to, or we want to keep track of the count, because let's say that this is an automatic counter. So now every time, so on first page load, we want to set a timeout wherein in 2 seconds, we want to increment the value of the count by 1, right here. And so, when the value of the count changes, this useEffect will know that, oh, it changed. And the component re-renders, there will be a new side effect wherein in another 2 seconds, we want to run this once again. Now, let's try this. Let's save this, render. There we go. And in seconds, there we go. There we go. Now, at first glance, this is very, very innocent to look at. But once I click this, like a gray, it does something like this. Now, why is that? Well, that's because every time we change the value of the count, we will have a new timeout. So when we have a new timeout, then, of course, we will increment the count by 1 based on how many timeouts we have. So in this case, let me refresh. Say we have, okay, 1, 2, 3. We have 3 timeouts now. There we go, 1, 2, 3, and then 4, of course, to include the first page load increment. Go 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now, how can we avoid this? Wherein that if, excuse me, wherein if there is a new re-render even before this timeout finishes, so like since it's a timeout, it will have a counter like 0, like from 100 ms, 200 ms, 300 ms until 2 seconds. We want to stop this timeout from ever occurring if the component re-renders. So now a component will re-render, for example, if the value of the count changes. And we want to clear the timeout because we don't want to increment the value if the count has changed. Because, well, the default behavior, or like the behavior that we want this useEffect to have or timeout to have, is to only increment the value by 1. We don't want it to do something like this. Then there is what we call as a cleanup function, wherein it will clean up anything that is left over from the previous render. So now, leftover is pretty much event listeners, subscriptions. So like when you have a third-party app that like listens live, and that's pretty much like an event listener somewhat, or intervals and such. So now there is a function in JavaScript, which is what we call the timeout, and it will take in the ID or whatever is returned by the set timeout function. So since we stored the value of what is returned by the setTimeout function inside of this variable called timeout, we just pass that over here. And now if I save this and hit refresh, we go 1, 2, and if I did this, it will still run normally. There we go. Okay. Now, why did that run only once, if you notice? Like, it only ran once. Well, if I'm not mistaken, that is because with straight mode, I think is that on first page load, it will actually run the function twice because of like when the component mounts or when this component renders and when the component finishes re-rendering or unmount as they call it. Okay. Whew. As you can see that it's now working perfectly, fabulously, and fabulously normal. So now cleanup functions are essential to remove leftovers on the next re-render. Do not have unexpected behaviors. Okay, now for the last thing, this is taking a long time, but anyway, let's talk about useRef. So now in here, I actually did it this way before to have automatic counters, but this is not recommended since I found a better way, which is to use useRef. Now what is useRef? Well, useRef is pretty much almost the same as state, but useRef is like an internal value that does not depend on the component's overall rendering lifecycle. So, for example, if the value of the useRef changes, then the component will not re-render at all. It will just change internally, just like how a variable would behave. So let's say we have a const if value equals to useRef, and we just want to invoke it like so. Of course, we want to import it from React. There we go. Okay. So instead of actually having a timeout here, let's just console log the count every time it changes. Like that. Okay, save it, refresh. Okay, nice. Excuse me. So now, this returns a value of an object, as you can see in the description. And we can have access to the current. So let's just say that we have a function or a button, I guess. A button wherein we want to start automatic counter, I guess. And on click, we can just say that we want to set an interval, excuse me, of every, oh, excuse me, why I'm not that versatile with my keyboard yet. Okay, anyway, every time we click on this function, we want to set an interval, excuse me, of every 2 seconds we want to increment, like so. And now there's another caveat for this, is that this will be the same as the useEffect every time we click this a lot of times. And by that I mean like the same as the useEffect from earlier, where we actually did not use a cleanup function. So like if I click this once, in 2 seconds, this will increment. There we go. And again, and if I click this a lot of times, you have a lot of intervals like that. And now to avoid this, we can just say that if interval exists, well, how can we say that? How can we know that it exists? Well, we can store the value returned by the set interval, just like the set timeout, inside of a variable. Let's just say const timeout, or interval rather. oh, there's a problem with this. Why is that? Well, just like earlier, every time we call a function, whatever is instantiated inside the function will only be available inside of that call. What does that mean? Well, that means that this interval here will reset. And by that I mean that we can do something like if interval, say, there we go. We can do something like this. And this is where the useRef comes in, because useRef, the current property of useRef, pretty much functions almost the same way as a variable. So in this case, we have ref value. So ref value dot current is equals to whatever is returned by the set interval. And then in here, we can just say that ref value, if the ref value current does not exist, okay, like that. If we don't have a value for the ref just yet, or for the current ref just yet, then we want to set an interval. So if we save this, like so, start the counter, and this will increment by 1, and just click this a lot of times, click, 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 nothing will happen. Beautiful. And so now, if you noticed, we're actually not, let's say, re-rendering the component. So if I remove the count like so and refresh, there we go, start the counter. So every time I click, I set the useRef to the value of the interval, or like when I click once. So let me finish it again. I will click this, and as you can see, it did not console log anything. And excuse me, based on what I said earlier, useEffect excuse me, useEffect is run every time the component re-renders. But when I clicked this and changed the value of the ref, it did not console log anything. That's because when you change the value of the useRef, the component will remain the same way. However, we would have changed the internal value of the useRef. So now this is useful if we want to change a value of something, but we don't want the component to re-render at all. So now how can we remove this interval, for example? Well, we can just have, say, a button, right? Oh, not there, but down here. Let's say we just have this as a stop. Again, there we go, stop. And on click, we want to have a callback function. And now to stop this set interval, we just want to clear the value of the current, like so, which is equals to null or undefined. There we go. And now if I save this and click the counter or automatic counter, we want to start it. There we go. 1, 2, 3, and now stop. Oh, why is this happening? I click stop, but it's still going. Interesting. Let's try to say that ref value is equals to null. Oh, that does not work. How about undefined? Let's try this out. Okay, refresh and start the counter. 1, stop. Interesting, once again. Oh, okay, excuse me for that. Not interesting, okay? I forgot that to clear an interval, even though we changed the value of the current ref for the ref value ref again. So if I did this, actually, this is a bug. So if I start the counter, we go, and click stop, and click this again, and click stop, and click this again, this will have a lot of intervals. There we go. Whew, this is very fun. Okay, anyway, so to clear an interval, we actually want to, well, clear interval, whatever value is inside the ref value current, and then we just want to declare the value of the ref value that current to be equal to null. Okay? Now if I refresh this, let's start the counter, 0 to 1 to 2, and stop. There we go. And now if I start this again, it will start the process all over again. So I'm curious again, is this really necessary down here below? Let's see. I refresh, start the counter, stop rather. Okay, start the counter again, stop, start. Okay, I think it's necessary to declare this as null. That's because we are actually asking over here in the condition if the value of the ref, if the value of the ref's property, which is called current, has a value or not. If it does not have a value, that is the only time we will run this below, wherein we will assign the value of the ref value's current property to an interval. And then when we click the button stop, we want to clear that interval and change the value to null, or change the value of the current property of the ref value to null. That means we can run this all over again. Okay, very nice indeed. And of course, over here, since we're only console logging the count, we only want to run this effect whenever the count changes. Excuse me. So now, if I start the counter, and even if I type something here, this is all independent from each other. And by that I mean that this state text is independent from the count, and the count is independent whenever the value of the text changes. Okay. Wow, a total of 1 hour. Well, most of the 20 minutes was from what we talked about earlier, from the function closures and such, currying. But anyway, I think that is all. Okay, that is all. Thank you so much for watching, if you stick around, and I hope you learned something about React, and of course about functions overall. It's confusing really, but if you have like built some stuff in React or JavaScript, then it will flow. Just like if you are playing chess for a long time, then you will be used to it, or playing or riding a bike for a long time, and blah blah blah. Okay. Anyway, just keep on practicing and good luck on your development journey. I hope that I helped you somewhat, because really this video is intended for my past self who struggled with React and JavaScript overall. But yeah, happy learning, good luck on your development journey, and goodbye, have a nice day.